Imagine a massive earthquake striking California's San Andreas Fault, causing widespread destruction and chaos. But here's the shocking truth. The next big one might not be the earthquake we expect. In fact, researchers are warning that it could be even more devastating than we anticipate. But what could this mega earthquake look like? Would it be a repeat of the 1857 earthquake that ruptured the fault from Monterey County to Los Angeles County? Or perhaps more similar to the great 1906 San Francisco earthquake that began just offshore and ruptured in two directions? The answer, according to a recent study published in the Proceedings of the National Academy of Sciences, is that we can't expect an identical sequel. The study, co-authored by scientists at Caltech, examined a massive earthquake that occurred in Myanmar on March 28th, which ruptured a much longer section of the fault than expected. This has significant implications for our understanding of the San Andreas Fault and the potential for future earthquakes. As Selene L. Antoine, the study's lead author, noted, "Earthquakes never come back exactly the same way." This statement is both reassuring and unsettling, as it suggests that while we can't predict exactly when and how the next big earthquake will strike, we can be certain that it will happen at some point. The study's findings are based on an analysis of satellite data showing Earth movement after the quake, which revealed that the earthquake ruptured an astonishing 317 miles of the Sagang Fault. This is the longest seismic rupture ever documented on a continent, and it has significant implications for our understanding of fault behavior. By comparison, California's 1906 earthquake ruptured 296 miles of the San Andreas Fault, while the 1857 earthquake ruptured 225 miles. The fact that the Sagang Fault ruptured in such a long and unexpected way has raised questions about the potential for similar behavior on the San Andreas Fault. As Jean-Philippe Avouac, a co-author of the study, noted, it came as a surprise that you could get such a long rupture. But here's where it gets controversial. The study's findings suggest that the San Andreas Fault is far more complex than we previously thought, and that it's unlikely to behave in a predictable way. This has sparked debate among researchers, with some arguing that the fault's complexity is due to its unique geology, while others propose that it's the result of a complex interplay between tectonic forces. And this is the part most people miss. The San Andreas Fault is not just a simple fault line, but a complex system that is influenced by a variety of factors, including the movement of tectonic plates, the buildup of stress, and the release of energy during earthquakes. The study's authors plan to develop a model simulating earthquakes over many millennia for the San Andreas Fault, which will provide a better understanding of the range of possible ruptures that could happen. However, as Avouac noted, it's not going to come soon because it's quite a heavy calculation. In the meantime, researchers are left to ponder the implications of the study's findings and to consider the potential consequences of a massive earthquake striking the San Andreas Fault. For instance, maybe the fault will rupture in smaller, separate earthquakes, or perhaps it will unleash a much larger earthquake that ruptures the fault from Monterey to Los Angeles counties, and possibly even further. Such a quake would be the largest simultaneous disaster in modern California history, with huge swaths of the state racked by powerful seismic shaking all at once. As Antoine noted, we can't just expect the exact same thing to happen. Instead, researchers must consider a wide range of possible scenarios, each with its own unique consequences. The study's findings also raise important questions about the nature of seismic gaps, which are areas of a fault that haven't recently ruptured. Generally, scientists would expect these areas to be more prone to rupture, but the study's findings suggest that even areas that have recently ruptured can still be susceptible to further earthquakes. So what gives? A possible explanation is the Sagang Fault's extraordinary smoothness, which can allow ruptures to propagate at high velocities and result in extremely elongated ruptures. The study also published the results of a computer model simulation looking at how earthquakes might rupture along sections of the entire 750-mile-long Sagang Fault. The simulation suggests that, over a hypothetical 1,400-year period, there would be no repeatable patterns. and that earthquakes wouldn't seem to reoccur like clockwork. Instead, the simulation reveals a complex and dynamic system, with each earthquake influencing the stress on the fault and leading to a bit of randomness. As Avuak noted, there is complexity here, and this is because each time you have an earthquake, it redistributes the stress on the fault, which is going to influence the next earthquake. This complexity has significant implications for our understanding of the San Andreas Fault and the potential for future earthquakes. While we can't predict exactly when and how the next big earthquake will strike, we can be certain that it will happen at some point. As Antoine noted, there will be an earthquake at some point. If there is stress building up on the fault won't hold forever. Further research and observations are essential to refine models of future possible earthquakes, including from the Sentinel satellites, which are operated by the European Space Agency. So what do you think? Do you agree with the study's findings, or do you have a different interpretation of the data? Share your thoughts in the comments below. And remember, the next big one might not be the earthquake we expect, but it's coming nonetheless. The question is, are we prepared?